So thanks everyone for joining us today. My name is Bilal. I'm one of the marketing managers at Data Science Dojo. I'm joined here today by Boyan Angelov. He is the Chief Technology Officer and Data Strategist at VAM, and he's going to be presenting on R and Python, the best of both worlds. So Boyan, why don't you take over? Thanks.
Excellent. All right. Thanks, Bilal, for this great introduction. And greetings from Berlin. I mean, as I understand, we have people from around the world. So here it's evening after the workday. So I hope everybody's fresh and ready for this. And I hope everybody can also see my screen. And today I'll be talking about one of my favorite topics, R and Python. It's a topic which has been dear to my heart since the beginning of my data science journey. One of the most common questions you get in data science. It was also, it resulted also in the so-called language war, which I'll be gladly talking about. And it was so important to me that I decided to write a book on this with O'Reilly. And today, hopefully, we can dive into how we can combine those two languages to do a great data science. So maybe a few words about myself as a beginning. As Bilal mentioned, I'm the CTO at VAM. We are a legal tech company, a Swiss-German one. We do a lot of data science, also a lot of data engineering. I spent my whole career as a data scientist, starting from academia, where I did mostly R. After this in industry, switched a bit to Python and a bit back and forth. And nowadays, of course, being bilingual. I also have my own consulting business. I did some work on explainable AI, which you guys can always see. I can send you the paper. We can add it to the link notes. And it's that work actually was done in R. And I wrote one book, Python and R for the Modern Data Scientist, which is again part of the giveaway today. We did this last year with Rick Scavetta, and currently I'm writing my second book, which is The Elements of Data Strategy, which is a bit more like a management-oriented book. And now maybe the first reason I think with every talk is we should set up some motivating factors. Why would we care about our tools? And I know it's very dangerous to attribute quotes on the internet, because they're often misplaced. And I do think it was correct that Abraham Lincoln said this one, but he said that if you give him 6 hours to chop down a tree, the first 4, he'll be preparing the tool, sharpening the axe. And I feel very, very strongly about this, especially if you are a beginning or mid-level data scientist. I would say you should really spend a lot of time on your tools. This is something which personally served me very well in my career. And it's important for your productivity. After all, you'll be spending a lot of hours in your working day working with the programming languages, open source packages, IDEs. So you should know them perfectly well. And this has compounding effects on your career. So the more time you spend at the beginning, the more benefit later. And of course, those tools that you select, in our case, we'll be talking about languages mostly. They have a huge influence on your career. So it really, it will give you different opportunities. So you should definitely pay attention to the tools that you have. And of course, as I mentioned before, the most common question which I got is, which language should I learn? And I heard it so often. And I would say this is a bit of a false dichotomy. Because it focuses, I think, on the wrong thing. I'll give you the answers a bit later, but I think we should be focusing on more on what you're trying to solve than the language. And actually, you can do both. It might sound very intimidating to do both at the same time, but it is possible. And I will discuss a bit later also about the language war, how those two languages, there was a bit like a competition between them in the data space. Another question, which is also common, is why don't we talk about other languages? And this ties to the fourth point here, is that this talk is from a data science perspective. And in data science, I would say there's one other language which is worth mentioning here, which is Julia, which I think has huge potential, but still is not nearly as popular as R and Python. So this is why we're not going to discuss it today, but definitely pay attention to that one. And remember, this talk is really from a data science perspective. So if you're a data engineer, this is not exactly the advice that I will give to you, because in that case, you might have really more experience with Python, might be more interesting things. It might be more interesting for you, more productive if you do Python. And the agenda today actually is I'll talk again a bit about the language war. I'll really dive into how those languages started, because you can see those effects still to this day. I'll see how you can really compare both one-to-one. Then we'll discuss two ways to look at programming languages. One is about what data format they're used for, and also another one is for which workflows they're more suitable. I will give a few notes about Reticulate, which is one excellent and very forward-thinking package from our studio. And then I'll show you an example case study, how we can really work with both. At the end of this, I hope that you understand that being bilingual is a great idea. Then I hope you see what are the differences between the two languages. They really are very hard to compare one-to-one. I hope you can then appreciate their open source ecosystem. And again, in the specific situation, those languages have different performances. So I hope you understand for which ones is better to use which one. There is opportunities to combine both of them. I want to show that as well. And ideally, after learning those things, I hope it will be easier for you to work with a more diverse team. So maybe you have somebody who comes from Python in your team and the rest of the people do R, or the other way around. And most importantly, what you see is knowing two languages, you get access to two communities. And yeah, maybe a list of bad questions, because all of those questions are really not good, except maybe the first one, which one is more popular, of course. There is a clear answer to that one, and that is Python. But the question is bad because Python, if comparing apples and oranges, Python is just popular because it's used for many other things. Then it has a more glue-like nature to it. It's popular for web development, for other things. So you really can't compare the two in that sense. Whether one is better than the other one is also not a great question, because the question is, yeah, at what should it be better? They're good at different things. What's easier to learn? Again, really depends on your experience. And the final question is what would make you more attractive to potential employers? Those questions, they're bad because they do not go into enough detail, and that's the detail I hope I can provide here. Maybe another thing which is a motivating factor for being bilingual is it makes you flexible. You can solve the same problem in different ways, and you might get stuck, for example, doing a data pipeline in Python, and you might just do a few steps with R. Could be much easier, and it's something which happened to me all the time in my career. More importantly, perhaps it allows you to have a new way of thinking about data. I'll show you two specific packages which are really providing that. A third point is you get more open source. You imagine as a data scientist, you need to solve all kinds of strange problems all the time. And for everything, almost everything, there is an open source package out there. And imagine now you double that amount. So you can be really safe in the problem that you want to solve. And as I mentioned, access to a new community. Exactly. So if there's any questions, by the way, as Bilal mentioned, feel free to write to them. I'll be having a look at the chat and the Q&A if I see something as well. But this is one of my favorite graphics here. It's from the Origin of Species from Darwin. It shows you the several types of bird whose beaks are formed based on the food that they eat. So if the bird has a larger beak, the seeds that they consume are larger. So it shows you how different things evolve based on their use. And this is very, very obvious in R and Python, how their origin still influences them, and the things they're used for are really good, very easy to feel. Python is a brilliant general purpose glue-like language. And R comes really from more statistics world. Both of those languages are not young anymore. You'll be surprised to learn that they're more than 30 years old, or around 30 years old. They were already around in the 90s. And back then, of course, there weren't, and programming wasn't still exploding like it is now, especially the field of data science, but those languages were there. And there were several key events in the history of those languages. Of course, as I mentioned, they were created a long time ago. And most importantly for R, there's three things which happened. R Studio, which is the company who created the IDE for R. There was a missing tool for that language. It was very hard to work with it without a nice tool. And R Studio probably made one of the best IDEs out there and made it freely available. So I would argue this was a big thing for R to happen. The so-called Hadleyverse, Tidyverse, open source packages. Hadleyverse comes from Hadley Wickham, who is one person who did an amazing job in doing open source R. He's the author of several very important packages. And the Tidyverse packages together, they really made R feel very modern, very special. And I think this breathed a new life into the community as well. So that was a very key event. And for Python, I would say in terms of data, the two most important events was the creation of the pandas package together with the whole PyData stack. So that would be also NumPy, scikit-learn. That's really when Python started to be adopted into data science. I think that was around 2006, if I'm not mistaken, so quite some time ago. And it heavily borrowed from R, that package. It gave you the ability to manipulate data in a great way. And of course, the whole machine learning space exploded in the last 10 years, and that was also key for Python for data science. Now, remember I mentioned that the language that you choose gives you, it makes you valuable in different ways in industry. And my experience and what I have seen in my career so far in talking to people is that those languages are popular in different environments. And based on your interest in where you want to develop, or perhaps where you come from, you might be influenced by their popularity in that specific field. I would say R is very popular for more statistically driven companies where you do more A/B testing, more Bayesian analysis, perhaps. It's very popular in the bioinformatics space. Finance, I assume also because of the time series packages, and business intelligence in general, because the data visualization capabilities. While Python, on the other hand, is extremely popular in software engineering. It's one of the most popular languages there. Data engineering, specifically, it's a field that I would always say a data scientist should know a bit about. Web development, some of the biggest websites in the world, Twitter runs on Python, I think Quora as well, other ones. And of course, machine learning, this is the most important language there. So depending on what you want to do, you might focus on different language. Before we wrote the book, we were thinking originally to create a one-to-one translation between R and Python. And we were inspired by the Rosetta Stone. Some of you might recognize this. It's in the British Museum in London. On one stone, you have the same text written in three languages. I think ancient Greek and Egyptian. Two forms of Egyptian, and in this way they could decipher the Egyptian hieroglyphs. And basically this one-to-one comparison we wanted to do. The reason why we actually decided to, instead of writing a whole book on this one-to-one translation, we decided actually to just have one small chapter on this, because you can't compare both of them. And one specific example of this is that vectorization, so the ability to compute through a whole list on each and every separate item of it sequentially, this is really built in R. You don't need any external package by default. If you make a list in R and try to do this, add an element to it, add one to it, every element will increment with 1 point. This, if you try this in Python, it's not going to work with base Python. And this shows you already that even basic data structures like this, they are different. In Python, you would need basically to use NumPy. If you're really interested in this, in the book, you can see also this one-to-one translation. If you do the giveaway and also the live online training, the O'Reilly platform, you can also see the bilingual one-to-one comparison if you really need that. We'll be talking today a lot about open source packages, and that's why there's a few points to what we should pay attention to. Again, in the book, we decided just again to use open source. We decided to use popular packages. I'll show you about the third point, how they integrate. The packages have to be well maintained. They have ideally to be supported by large organizations, and they should have good documentation. So I'll try everything that I show today is based on those principles. So now to proceed with one way that we compare the two languages and their packages is the data format context. And the data format is the way you store data. You can imagine, let's imagine a typical perhaps data science workflow, and way of working is you start with some data here at the beginning, and then at the end you want to have some kind of a machine learning model. I'm not saying it's typical, but let's say most people are familiar with such a workflow. You see the steps in between. This is where the big differences happen. And here I have the visualization showing how those steps differ for different data formats. I have selected those 4 data formats. There are more, but by far I would say those maybe 80% of data science is based on such formats, beyond normal tabular data, of course. So that would be image, pictures, of course, you could put video there, of course, as well, text, time series, and spatial data. And how you prepare this data for a more like specific purpose, like machine learning? It could be even a report here as well. This is where there's huge differences. Perhaps the data import and training the model, they don't differ that much, but between the different formats, but normally there's really big differences. So you need to pay attention to the data format when you decide which language and which package you want to choose. And I want to start with image data. And here, of course, to give you some legend to the presentation, there's also the logo of the language, which is better suited for this purpose here on the top right. And image data is, of course, mostly nowadays used in the use cases for machine learning. Of course, a lot of deep learning is done there. You could, the whole self-driving car field is based on such methods. And it's done mostly in Python. And I want really to show you why. In Python, there are several packages for doing, to process and working with image data. The most popular one probably is OpenCV and scikit-image. And of course, deep learning Keras is one extremely popular example. If you try to do a normal, if you even try to plot like an image in R, you can see there's no big difference between those two scripts. So on the left, you have R, and on the right, you have Python. You might look okay, both of them are 3 lines of code. Unfortunately, the devil is in the details. The image that you load with the library Magic, which is the standard for R to work with such data, the image will be of a class Magic image, and this makes it suitable for analysis only by specific packages. While if you use OpenCV to load the same file, it will actually load it directly as a NumPy multidimensional array. And basically, this allows you extreme flexibility. What do you do with this? You can, for example, just remove one color by removing the last element of this of every NumPy array here. And this huge flexibility is explained in the next slide, where I talk about what is good package design versus not so good one. And this shows you what I just described. Why would we choose Python versus R in this case is that once you go from the raw data, you immediately go to a well-maintained open source package like NumPy. After this, you can use all kinds of other tools, whether you use Keras, scikit-learn, anything goes on top of NumPy. It's very easy. You don't need to create your own open source on this. Things just work. While in the case of R, in that case, as I mentioned, after loading the data, you have it in this strange type image magic, and it might not work with everything that you have in R. So that really limits you in the type of tools that you have. So here you have like my analogies. It's there's this expression in English, it's turtles all the way down. I would say it's NumPy all the way down. So when you look for open source, try to find packages which are really like this. If you have any questions, by the way, at this point, just write in the chat or in the Q&A. So continuing a bit on text data, again, at this point, you might think that this presentation is one-sided because I have Python again. And yes, Python is great for doing text analytics, natural language processing, machine learning based on text data. All of those things are great in Python. Again, there are packages in R which do that, but for the reasons we mentioned before, Python is great. Several packages which really I recommend you trying to see how great they are NLTK and Spacey, starting with them. NLTK is a standard Python package to do text data stuff. Spacey, on the other hand, it's really, with those several lines of code, I'm not sure how many of the attendees are familiar with NLP. On the some simple sentence that we have here, with one line of code, you can get this beautiful dependency graph. Basically, it splits the sentence into words and shows the relationships between them based on a pre-trained model. In this way, for example, if you have a bigger paragraph, you can visualize the different parts of speech. For example, here we have dates, we have some kind of an event, we have money, financial information here. And you can imagine the beauty of having this just with like 1 or 2 lines of code. And stuff like this you just wouldn't have in the R packages. And again, the reason why you want to use such packages is that it will be easier for you to do even more advanced things later down the line. So of course, deep learning is everywhere nowadays, and it's definitely something that you should keep in mind. Again, the packages interconnected. Now let me go to another very interesting package here. That's the first R recommendation I'm going to make today. And this is, as I mentioned, the reason why R is very popular in the finance world, because you deal with a lot of time series data. In R, the time series functions are just built in. You can use a TS function to load the data set into a time series object, and then you can plot it immediately, and it will work. In Pandas, of course, recently there was some nice developments about time series and visualization, but it's not that advanced as R yet. The plots that you see here, they're from the library called Prophet. This is by Facebook, formerly Facebook, now Meta. It's a brilliant library which allows you to do very advanced predictions. Here you can see time series decomposition plot, where you can see, for example, you can remove the noise from the data. You could try to see what the trend is. On the right-hand side, also you want to fit a model to a time series data set and see the predictions. And this is a brilliant package because this will be achieved just with several lines of code, and you don't need to be an expert to do that. Prophet is a brilliant example for us because if you go to the website, which I encourage you to do, it's very well documented. So Facebook, they did it in both languages. They did the same package in Python and in R, and the API is almost the same. So it's a very interesting decision for a big company to do a package in both languages, but it shows you again the popularity of R for time series. That's why they did that. Okay, so let's go now to one of my favorite examples. This is mostly my open source work, and this is the spatial data format. And spatial data is any data set which has coordinates on this, and you want to do some kind of analysis on this. For this, I would argue that R is also better here. Based on my experience, there is some extremely important packages here like SP, RGDAL, and the package that I have here is SDM Bench, which is my own package, and it combined a lot of other R packages together. And SP in RGDAO, for example, and the whole spatial data in R communities built in such a way, in a very similar way to NumPy and the PyData stack. So those formats are very interchangeable, and you can put different functions together and build very nice solutions. I see some, yeah, that's one question from Harry I see about how do you integrate with popular libraries like MXNet, TensorFlow, SparkML, IGBM. All of those libraries that you mentioned, Harry, these are machine learning libraries. I'll come to that in a second. But this is an excellent question because it shows you this is the right way to think about the problem. The tool that you use is better if you can combine it easily with other tools. And the examples that you mentioned there, they're really well done in Python. So we'll come to that in the machine learning part. But again, for spatial data science, R is just wonderful. Now let's go into the second way in which we'll be comparing the different languages and different packages and how they fit different workflows. And first thing you might ask is what is a workflow? And I think many of us have seen this crisp DM diagram where you can see how you can start with gathering data, then you visualize it, then you prepare it for analytical purposes, and then you perhaps create a model and report your results or deploy the model. So this is what I mean by a workflow. And nowadays, maybe data science became very specialized in a certain way that every part of the data science workflow became a whole job in a way. You might argue that the data munging or wrangling is a data engineering's job or deployment as well. EDA is for business intelligence, perhaps. So it's splitting into different workflows became even more important. As for the data format context, different languages are strong at different things. So let's have a look there. Exactly, one great comment from Kostadin. I see that base-R and tidyverse are very different accents. Exactly. So it's basically you learn almost two languages, I would say, and I think this is the great contribution from Hadley and everybody involved. All right. So the first workflow we will cover is exploratory data analysis, basically visualizing data. This is one of the packages which teaches you a new way of thinking about data. So if you're a Python person who has done some data visualization or wants to do more, I think it's a must that you at least have a look at this package. I'm not saying you need to use this, but it will show you a new way how to think about plotting things. And I recommend really reading the papers. It's called Grammar of Graphics by Hadley Wickham. And the idea is visualized here. Basically, every plot that you make, it can be split in different layers. And those layers you add on top of each other, you can move them around, you can extend them very easily. And for example, the grid behind the plot is one layer, the data is another one. And here you can even do modeling inside of the plot itself. And the labels become like the numbers on the data points, for example, they become the third layer. I think exactly, I see another great link there, so have a look at that. It's a brilliant way to do data visualization. And once you try ggplot2, once you learn its syntax, again, this goes to what Kostadin mentioned, because it looks very strange at the beginning, how you construct a ggplot. And you basically have to learn the syntax a little bit, but it's extremely powerful. And you can create beautiful plots in it. It becomes even sometimes more art than science. So really check this one out. A second brilliant R package, which has saved me so many times as a data scientist, is dplyr. And this, again, it's called the grammar of data wrangling. That's a good way to put it, because it borrows very heavily from the concept of chaining. Those who are more like a command line command line people, they know that you can chain the output of one command becomes the input of the next one, and you can make very powerful pipelines like that. Something not so easy to do in pandas. You can do it, but it's more tricky. And I think the best way to visualize is with an example here. And this uses this syntax, which is, we do have some alternatives to this in Python. There's similar packages to this, which try to do the same, but it's still early. Basically, this data set becomes the input of the function, and then of the next function, which is group by, and then the result of this grouping becomes the input of the third function, where you create a new field, basically, and you compute the calculation here. So in 3 lines of code, you create from a very different data set, which didn't even have this column, you create this output. And in the book, there's some more specific examples. If you read the documentation, you'll find how great this is. In several lines of code, you can do such elegant data pipelines. This one saved me for productivity many times. So I was struggling to do certain things in Python. I would just put it in dplyr and create very good data processing pipelines. And dplyr is also good because it's also integrates nowadays well with even larger data sets. It's one common complaint people have about R is that it's just for small data. I would say nowadays it's not really true. We can work with the big data sets also in R. I would argue it's not as easy as in Python, but it is doable. Now, continuing with machine learning, this is the question I think Harriet was who mentioned. Here, Python is king. And I would argue this is because of the glue-like nature of the language. Is that to do successfully machine learning nowadays, where if you don't deploy your model, basically your work is not very useful. You need to interact with all kinds of different systems. So you would need to connect to a database. You would need to execute those scripts on a remote machine, which is limited in memory, perhaps. So it has to be very efficient. Then you might have some kind of a library to check the performance of the model that you train. And then finally, you need to connect this model to something. In many cases, you want to expose it as an API to another system. So doing many of those parts in R is almost impossible. There are packages for all of this. For example, you can make an API with Plumber. There's a package name. You can do quite a few of those things, but they don't play very nicely with other systems. So in Python, you have a connector to any type of weird, strange database, because not at every job you're gonna have the luxury of having a MySQL database or Postgres. Sometimes you might have something more specialized, like let's say InfluxDB, which is more for time series. And there you'll be stuck if you just know R, basically. And as a data scientist, you would need to do such thing, like such glue-like work, even if you don't do machine learning. But the ecosystem here, what we have in Python just fits perfectly well together, and new tools come every day. The ones that I list here, they're just tip of the iceberg. All of them work very close together. One example about why some packages are also good is the API consistency. When you have done this for some time, I mean data science, you expect certain things, and you don't need to look at documentation with every. That's a great actually point from Harry. It's also what we mentioned in the book, right? Exactly. Hadley basically created the package. But the work on ggplot2 is from Leland Wilkinson. Yes, exactly. It's correct attribution. So the grammar graphic is from him. And yes, come back to the API consistency. And here, the fit predict paradigm, it's everywhere. So you have it in scikit-learn, where you fit a model. You have it in Yellowbrick, which is a Python machine learning model visualization library. You have it in Keras and many others, which I didn't this year. In Prophet, you have it too. And you don't need to look at documentation. You just know how things should look like. You can really expect this. So this API consistency is a huge point for many packages working together, and this is what makes Python great for ML. And again, now coming back to, I see Kostadin also mentioned this reporting. I'm glad you mentioned this, and reporting is just great in R. And by reporting, we mostly mean the concept of literate programming. I think that was created by Donald Knuth in the US some time ago, where you mix text, normal language with code. And this became very popular some time ago. You can do this with R Markdown in R, where you can combine beautiful plots with really well-formatted text, which you can export as HTML as a website. You can export as a book, what we see also in the chat with Bookdown. You can export as a PDF if you want to have a paper. It's just great to do reporting there. And RStudio offers some services to, I think it's called RStudio Connect, where you can really share those reports with the rest of the organization. In Python, what we have, and to be honest, the R in Jupyter stands for R. And so Jupyter, again, it's mostly associated, this project is associated, of course, mostly with Python. But of course, you can have R kernel there as well. You can also write R in Jupyter, which is great. And Jupyter has a lot of those things going on for this. I would say it's not as nice as R in some things, mostly because R Markdown is very friendly for version control. If you add things to version control, it would just behave like any normal text file. You can see the diff. While for Jupyter Notebooks, unless you do some more customization, you basically, I think it's a JSON-like file, and every time you execute a cell, then you won't be able to use version control very well. I see in the chat that also Harry mentions that Python has several here nice libraries, which I should mention as well. Nowadays for reporting, right? So Bokeh Dash, so Bokeh, it's a nice data visualization library. I think it allows you to do interactive visualizations. Dash for dashboards, and Streamlit. Streamlit is a really interesting one. It's very new. It still needs some time, I think. And I'm not sure about their model, how focused they are on open source. So this is why I actually prefer Shiny, because it's a bit more clear that it's really open source and that is going to be maintained in that way. But Streamlit is really, really great. I see that a question from Anil, whether we can recommend R Markdown for machine learning. I mean, yeah, if you do machine learning with, I would say if you do exploratory machine learning, basically training your model, preparing data for this, R Markdown is good. But again, the issue here that we have is that I would recommend Python for machine learning. So in that sense, you might have some issues. I'll show you how to combine Python and R Markdown in a second. But for version control, the normal version control would say that you really should use R Markdown. It's much easier. Shiny is a great package which allows you to do these interactive documents where people can do their own analysis, basically. It has one drawback that you need to have basically an R backend for this. And this is the example of Shiny, actually, again, from my package. You can make those like really nice interactive, it's more than a dashboard because those plots are actually generated from the interface to the left. So you can really create just applications basically based on data. And it's very, very easy to do in Shiny, I would say. Again, Streamlit, check this one out. But on Shiny, keep in mind that it's it's hard to set up, it's hard to share with other people unless you have a premium subscription or something. So this might be an issue. Yes, and yeah, feel free again to ask questions. I think there's some good questions there. This package I hesitated to put in the book. We have it in the book. I think it's a very forward-thinking package. In the book we criticize this a little bit because it's early days, and I think you should always approach new packages or packages which are, a bit experimental with some caution. But it might be where the future is going. So the package Reticulate allows you to work with both languages in the same environment. And that's very strange the first time you do it, I have to admit. You here on the right, you see a screenshot, and here you can see like a Python chunk, like a small Python script, but then you see ggplot. And here, if you pay attention, actually you load your data in pandas, then you visualize with ggplot. So basically any data, all the data is shared between the two languages. I think that's very, very interesting. This is very useful for one specific case. It's easy to illustrate the purpose of this is when you have a colleague and who knows Python and they wrote the work in Python, right? But you need to use it in your R script, for example. So instead of recoding all of this, you can just load the whole script. There is a function from Reticulate to load the whole script. So all data frames, all functions, you'll be able to load into R and do everything you need with them. You can actually use the functions. So this is a very, very interesting package you should pay attention to, and perhaps it's one of the future developments in this field. Now, in the book, we talk about one case study, how you can really combine those two languages. We practice what we preach, because as probably till now you saw, some languages are good for some parts of the pipeline or workflow or some format, and the other one for other parts. So actually you need to mix sometimes. And for our case study, we used a data set of forest fires in the US. I think it's quite popular. It's on Kaggle. Actually, there's a question from Mary whether we can do Reticulate in Colab. So on Google Colab, I can give you, so Google Colab, for those who don't know, it's a tool in Google Drive, actually, that you can create a Jupyter notebook for free in a way. You don't need to pay for this. And you can do data science in your browser, and it's stored as a normal file in your Google Drive. There is a trick you can search for on the internet, how to use R in Google Colab. You can have Google Colab with an R backend. And this is why I think you can use Reticulate there as well. But something I'm not 100% sure, but you can use Google Colab with R, which is great. And I really recommend it too.
Boyan, we do have some questions in Q&A tab. If you answer those, that would be helpful.
Yeah, we come back. I think it's almost finished. I think there's like 2 or 3 slides, and then we come to the Q&A. Sure. We can answer those.
Sounds good.
Exactly. And this data set, we did the data processing in R. We deploy, of course, favorite package. This beautiful data visualization you see here and done in ggplot. The interface in Shiny. The backend was with some of the packages I think Harry mentioned, like XGBoost is there, scikit-learn. So all of those we combined together in this beautiful case study, and it just allowed us to be very productive. So I think that's a great example how those two fit together. This is a summary with my recommendations. You'll see the slides after this, so I don't need to go through all of this. But just remember, in those 2 different format and workflow, 2 languages have differences. These are my personal recommendations. This might change, of course, in the future as well. As a conclusion, I would say, I hope you now see the point of being bilingual. It's not easy, but I think the benefits really outweigh the efforts that you need to spend. Remember that the tool that you use, it's like, you have to pay attention to which tools that you use for the job. And you should focus on the job, not the tool, I would say. And be very open to a new way of thinking. The weird ggplot syntax, the weird dplyr syntax, the API consistency of Python, some pandas things. These are ways of thinking which are not available to people who don't know the language. So I would really, really recommend you to check this because you learn a new way of thinking about problems. And again, there's enough data science problems for everyone. So just, keep solving those problems. Now, final slide for me is there's a few resources that you can check out. My company's website, my website, the book website. We did a podcast with Rick for Data Framed, where we talk exactly about this. There we talk a bit how this influences your career. So if you're interested in that one, I think Meng Chu asks about which book this is, Python R for the Modern Data Scientist. And I think you can be a part of the giveaway, so you can get that one for free. And you can read this with the free O'Reilly trial that you can have, like everybody can have here. Follow me on Twitter and LinkedIn, of course. I'll be happy to answer any questions, feedback, anything. Just write to me if you need any data science advice or about the languages. But yeah, that was it from my side.
Okay, that sounds good. Can you look at some of the questions in Q&A tab? If you're unable to, I can read it out to them for you.
Let me check. So Anusha wants to learn to do data science live projects from websites or institutions. I mean, learning data science, there's so many ways. There's so many ways to do it nowadays. I would really recommend starting with, for R, there's a package called Swirl, which perhaps might be what you're looking for. That's a very strong recommendation for me. This allows you to learn R by doing R, actually. So this is, I think, very cool. I would say I think Python is a nice place to learn on Code Academy, Data Camp, Data Science Dojo, of course. O'Reilly have great places, but I would really recommend try to work with real, yeah, thank you, Regan. Try to, instead of perhaps using that many websites, try to really find the task, right? Maybe have a look at the case study we did in the book. As I said, you're going to have the O'Reilly link for free, so you can take the trial, and you can just, if you just don't have the time to read the whole book, just go to the case study, Anusha, and try to get to see what is an example data science problem you might solve. And that's a much better way, I think, to learn data science. Exactly. So Harry, any comparison for calling one language from another? Yes, Reticulate, RPy2. Yes, we covered this a bit in the book. My impression for comparing how do you call those two languages from each other? Reticulate seemed very flexible. R to Python goes in the other way around, right? So one is a bit more Python to R, so that's Reticulate. And R2Py, I think it's actually, that's R to Python. My impression is those languages are, projects are sometimes more pain than help, right? So calling one language from the other, I think if you can avoid it, you should avoid it. Try to kind of separate the scripts and kind of work on the outputs. For example, what I would do is use dplyr to do my data processing, then store the intermediate result as a CSV, then load it into pandas, instead of really doing a scikit-learn on the dplyr result, for example. So I think it's better kind of to split the scripts at least. Luis asks about TensorFlow. TensorFlow, yes, this is in R. You have an R package, R TensorFlow, you have R Keras, and these packages, the issue with them is that they are a bit, they're like wrappers. So actually you write R, but under the hood is doing Python. Nothing wrong with that, right? It works until it doesn't, because TensorFlow specifically, it's not as easy to use as scikit-learn, and doing deep learning is a bit harder in general, I would say. And things will break, and debugging a wrapper, basically debugging a package which calls another package, is very, very tricky. So I wouldn't recommend using the R TensorFlow package or the R Keras. Basically use Python for that. R Markdown, whether it's compatible with LaTeX, yeah, it's LaTeX is compatible, right? You can, I think you can combine them very well. You can, I'm pretty sure. You should just check that. Whether scalability of terabytes or petabytes between the two languages from Harry, distributed runtime capability. Good question. I'm not sure whether it's very easy to move so much data between two of them. And I think Python in general, loading a lot of data into memory. For Python, you have, I think, a package called Array, I think. There's just nicer things there for bigger data set. If you can learn both languages, which language is preferred when looking for jobs? Okay, that's I mentioned it depends in which field you want. If you don't care whether you work in bioinformatics or finance, you just data science in general. If you want to go into machine learning, specifically do Python. That's basically it. If you want to do machine learning in academia or more like statistical modeling, that's a different story, but I assume you talk about industry. So for ML, do Python. But if you data science is much more than machine learning. So there, I think the question is where you live, also for what type of companies you like. Again, if you try to get a job in a financial company, they might be very happy that you know R. And this also is representing salaries and everything. So yeah, for data science in general, again, which language is preferred, I can't say. It depends which language it's easier for you to use.
If we have a minute, I can announce the winners for our free ebook.
Yes.
So congratulations. We have 3 winners: Samar Binkender, Jamila Bell, and Tam Morgan. Thank you so much for participating. We'll send you details on how to receive your free ebook over email. Thanks, guys. So you can continue, Boyan.
Exactly. I mean, there was one question about whether you can use, whether I recommend learning both languages together or one by one. I would say one by one in this case, especially if you're real beginner. So you've been starting maybe months ago, then you do them one by one. If you're a beginner data scientist, you would just be too confused between the two syntaxes. It would just confuse you. If you're a very experienced person, if you, for example, come from another language, I don't know, maybe C, maybe Java, if you're very good at learning coding languages, then you can do them at the same time. But I would really think about the problem you try to solve. So this is from an anonymous attendee. I don't see the name, but look at the data format versus data workflow comparison I did, right? If you want to work on machine learning, on image data, you can see which one you should learn, right? So you can check that to compare. Yes, sometimes it's lazy code from Kostadin. Yeah, okay. Yes, that's the thing. I mean, R is often used in academia, and of course, not everybody. Like I come from that, right? From bioinformatics, so it's you get a lot of bad R code on the internet. But you could say the same about Python. A great comment from Seattle Go Center. Learning Oak first. Oak is great. So it's like a command line tool. I can really recommend that one. Also learn the command line. That I can say. Command line, there's a great book, which if you, again, I don't want to plug O'Reilly too much, but on O'Reilly, the learning platform, you can get also this great book, which is Data Science at the Command Line.
And since you guys stayed till the end, we just announced free 1 month access to O'Reilly and 40% discount code, which you can use, and you can find that in the chat. And for the winners, we'll send you details over email. So yeah, I think those are all the questions today.
Maybe just one final one. There's one final one. I would really love to answer that one. I think it's important about the intermediate data scientist, how we should go about from Mahdi. For intermediate data scientists, I think you can focus on the basics of the languages, right? Like you can really try to get some of those books like Fluent Python, and I think there's R for Data Science, those 2 books, and focus on the languages themselves, focus on the really interesting differences for them. For example, how would you do a list comprehension in Python, right? And could you do such a similar thing in R? That's so you should really not focus that much about data, but the language itself. So intermediate users, data scientists should do that. But yes, if there's any other questions, I'm happy to answer them in LinkedIn, Twitter. Please go ahead and write to me.
So yeah, this was great. Thank you so much, Boyan. It was a great presentation. We received a lot of interaction. Thank you so much, guys, for joining us today. And special thanks to Fatma and rest of our marketing team for arranging this. So we do have a webinar scheduled for this month, June. Make sure to RSVP for our upcoming event. The next one is happening coming Tuesday on June 7th. It's 6 business skills critical for data scientists. It's being presented by David Stevenson, who's a managing director at DS Analytics. Make sure to RSVP for that. And with that, thank you so much. It was great having you, Boyan, and thanks
Thanks,
everyone.
everyone. All right. Bye-bye.